Let's look at one more example of a double integral, just calculating a double integral. So I already have this one set up with the x bounds on the outside and the y bounds on the inside. If you did rewrite this one in the other order, with the x integral on the inside and the y integral on the outside, you would get the same thing that we're about to get. Let's do it in the order that I've written it in here. So integral from -2 to 2, and then we need to do a y integral, so this is going to give us x times y. And then we need to evaluate from 0 to 1 dx. Okay, so integral from -2 to 2 dx of, and now we need to plug in our bounds. This x, we can sort of factor that out, and remember, as far as plugging in our constants is concerned, this x looks like a constant multiple, so we can sort of move it to the side and distribute later. And then plugging in our bounds, we get 1 minus 0. So we're just calculating integral from -2 to 2 of x dx. Okay, so that's going to give us 1/2 x squared from -2 to 2, which is 1/2, and then plug in our bounds. 4 minus 2 squared is 4, so this is 0. But this might seem odd at first, because remember, our interpretation for a double integral was that this is the volume between the graph and the patch in the xy plane that's determined by the bounds here. So I mean, in this example, that volume definitely isn't 0, so why did we get 0? Well, the resolution to this little puzzle is essentially the same in this multivariable case as it is for the single variable case, right? In the single variable case, a double integral gives you, if you do a double integral, it gives you the signed area under the graph. So any portion of area above the x-axis counts as positive, but any area below the x-axis counts as negative. And because we're sort of accumulating this area, the negative area can cancel or partially cancel the positive area. Well, exactly the same thing happens for double integrals. It gives you not just volume between the graph and the xy plane, but signed volume, right? And by signed volume, any volume above the xy plane counts as positive. Any volume below the xy plane counts as negative. And if you are accumulating positive and negative volume, then of course it can cancel or partially cancel. And that's what happened in this case, right? In fact, the graph of this function, x, is actually just a plane that is sort of going up as you go in the x direction, right? And this bit of volume below the xy plane on one side is exactly balanced by this bit of volume above the xy plane on the other side, and so they cancel and give 0. So whenever we use our geometric intuition that a double integral gives us the volume of under a graph, just be a little careful that it's actually the signed volume, and that you can have some volume that cancels.